Good evening, everybody. My name is Adrian, and I am the coach of the Carnegie Mellon University team. Before we present our problem statement, design decisions, and current status, I would quickly like to introduce our team to you. Our two customers are Professor Vivian Loftness and Paul Schmiedmeier. Our project leaders are Dominik and Florian. And finally, we have 9 awesome developers without whom this project would not be possible. They are David, Philipp, Tobias, Thomas, Maximilian, a second Philipp, Nina, Elisa, and finally Maya. And now, to give you a first impression of our project, we will show you our trailer.
Thank you. My name is Philip, and I'm going to present to you 2 of our visionary scenarios and to let you know what the core aspects of our product will actually be. So let's say there is an occupant, and he is in a workplace with a smart environment, and there are many devices connected, for example, lamps or blinds, heating, or basically anything that's connected to a power plug. And of course, he wants to control these devices, and he wants to control them as easily as possible. So our product enables him to use augmented reality so it's easy as possible. That will be what it does. And another visionary scenario would be that the occupant might wonder what his green footprint is, or his statistics, what they are. So our products allows the occupant to look at different kinds of statistics. For example, a personal energy consumption comparison to see how he's doing in comparison to all other occupants, and by that, motivating the worst to do better than that. And also, a device energy consumption split up by categories, so the administration of the building knows which part or which category uses the most energy, and therefore where to improve on that. A daily or weekly energy consumption will also be included, so you know by the end of the day how much energy you used. That's it for the visionary scenarios, and now over to Nina for the functional requirements.
Thank you. Along with the visionary scenarios, our customer defined certain functional requirements. Our solution should enable the tracking of energy consumption to enable comparison. We should utilize location awareness to determine the position of devices automatically. An occupant should be able to add new devices to a smart environment and discover existing devices using augmented reality. And based on these, we created the following analysis object model. Imagine an office environment with many IoT devices. These devices are various states such that they can be turned on and off. An office environment has multiple occupants who may in turn have many workplaces. These occupants may want to perform certain actions in order to control devices in their vicinity, changing their states accordingly. Depending on the size of the environment, we could be talking about hundreds of devices controlled using a central control unit that is aware of the occupants in the area. This can be very overwhelming, and this is where our solution comes into play. We introduce fog nodes into the architecture connected to the central control unit. Occupants can add devices to these fog nodes and communicate with them using the given communication protocols. We display the devices using augmented reality to enable the interaction between the occupant and the IoT device. And since we've mapped the functionality of our system, let's move on to a more technological perspective. We leave out the office environment because they can be represented by the fog nodes themselves. And in order to transition to the subsystem decomposition, we first add visibilities to the publicly accessible methods. Then we identify the packages in the system. In our case, we have the smart system, fog node, central control unit, and the intelligent workplace app. These packages need to communicate with each other. This is why we introduce the communication interface and the fog node interface. The final step would be to combine classes based on their functionality, a point to which my colleague David will explain to you.
In our component diagram, we start in the fog node system, which deploys an AR map provider that supplies the IW app with an AR map and the location of the IoT devices. The AR visualizer can then detect an IoT device when an occupant aims at it with the camera of a smartphone. It's connected to a smart device controller in order to enable the occupant to trigger the respective commands for each device. The smart device manager of the fog node then receives such commands, converts them to a device-specific format, and forwards them. On successful execution, it also sends a log statement to the energy consumption reporter containing the occupant, the device, and the command executed, which the reporter then stores at the central control unit. Upon request of the IW app, the reporter retrieves past actions from the central control unit in order to calculate energy consumption data on a per-occupant basis. The energy data handler then converts such information into a visual format intelligible to the occupant. Now that you've mastered our subsystem decomposition, the hardware-software mapping will be a piece of cake. For example, Raspberry Pi. Our client applications run on all iPhones supporting ARKit2, and our fog node applications run on Raspberry Pis. The Livix light bulbs run their manufacturer's control logic, and on the CMU server, there runs an OpenHub instance connected to a database. While FogNode and OpenHub are accessible via RESTful APIs, we interact with our light bulbs through their proprietary Livix LAN protocol. And now, please enjoy our live demo taking place at the CMU's Intelligent Workplace. It's late at night. And there's only one occupant left.
How can I turn off these lights? There's no switch or anything. Darn it, let's just leave.
Excuse me, don't you think that you've forgotten something?
Yeah, actually, I don't know how to turn off these lamps.
Really, you never heard about the AW control app?
No, what is it?
You should, I will show you, but the app featured augmented reality. But the app featured augmented reality to control the devices. So let's move to your desk.
Yeah, sure. My desk is over here, and that's a lamp I can't turn off.
Okay, so let's just open the app. And once you move to the lamp, you should see a label on it.
Yeah.
Just click on it, and it should be turned off.
Wow, that was quite easy.
Yeah.
You know, there's another lamp on my desk. It has been off for the last 2 weeks. Probably you can help me out here as well.
Of course, let's see. Oh, I think it's not yet added to the smart environment. But if you want, we can change it now.
Yeah, can you add it?
Of course, just click on the add here, place another label here, click on save. It's a desk lamp, and I think it's also a Livix lamp, so let's just choose it. And now you should be able to turn it on and off again.
Wow, that was very intuitive.
Yeah.
Now I'm actually wondering how much energy gets wasted through all the occupants in here not knowing how to control any of these devices.
Oh, it's a good question, but it's really late outside. I need to go home. Let's talk about this another time.
What do you think about the 7th of February? This might be a good day to discuss this.
Sounds good. I will see you then.
All
Bye.
right, bye.
Okay, after this great demonstration, the only question that remains is what technological milestones we have reached. So in the last weeks, we had 5 sprints, and they were creatively named after different kinds of beers, as you can see here. And you saw already in the requirements what we wanted to implement. And so far, we were able to set up the infrastructure using fog pattern. We can add new devices, as you already saw, in the live demo as well as control them via AR. And there are 2 big steps left which will be implemented in the next following weeks. One of them is the energy consumption comparison, and the other one would be the location-aware features. So that would be it. Thank you for your attention, and see you all at the client's acceptance test.